we have the latest high-end titles. Again, some marketing thing. We cut deals with these publishers so we can get the games the same time they hit the stores. So we're not going to be a back catalog company where I can have games that are brand new. And the games are instantly available for play. I mean, you can find things that call themselves video game on demand services, and they say, okay, here's your 20 gigabyte download. I mean, literally, you might take a day. Well, not here at Columbia, you got great networks, but for normal human beings, it might take you a day to do a download that large, all right? But you can play a 20 gigabyte game instantly and then switch over to another 20 gigabyte game if you get bored with that one. But Onlive works on any device, okay? You can work, the exact same version of the game runs on a TV, a PC, and a Mac. So for a PC or Mac, we just have a 1 megabyte plugin that goes into any browser, and off you go. You don't need a GPU or any high-end hardware. For a TV, we have this really cool thing called the micro console. And I'll explain what that thing is, and I'll give you more detail in a second. But the micro console allows you to hook up a TV to your DSL cable modem, or your, as we're using it here. By the way, is it working on here? It isn't. Okay, we're going to have to switch to this screen here. But anyways, the micro console allows you to hook up a TV to your broadband connection, and that's it. You can get access to all the games. So what's cool about this, because the games, I'll explain in a minute, are running in the cloud and servers actually in Virginia for the East Coast that are 250 miles away, you get unprecedented performance, and you never need to upgrade, all right? Because, of course, we just upgrade the servers in the cloud, and off you go. All right, so we call this thing the most powerful game system. Again, more of a marketing term. There's actually nothing in here at all. Do you have the other box? Because we'll pass that around. Because nobody believes it, they're saying this is a liquid nitrogen cooled something, all right, with a supercomputer in it. That's why it works. We said, no, dudes, it's like got this many chips in it. So we put it in an ugly box with a plexiglass top. But anyways, what you do is you just plug in your DSL cable modem or whatever. You plug in HDMI to your TV, hook up surround sound if you want, and then we have work with a wireless controller, which you'll have a chance to do. Or you can plug in any USB controller, keyboard, mouse, guitar, whatever you want. And what's really cool is there's a little button here which will pair it with your Bluetooth headset used with a cell phone so that you can have voice chat with people. And we will pass this around for people to look at. And it's so inexpensive that the case actually costs more than the chips inside of it, a case and connector. So we'll be in a position that we can give it away with if you sign up for a subscription if we want to, or charge very little. Okay, so this is how Onlive works. You start out with your PC or Mac where you have the 1 megabyte plug-in. If you hook it up to a TV, you hook up the micro console. And then we have our servers sitting in the internet, and I'll explain in a minute. They have to be within about 1,000 miles. And the games are running here. So you hit a button on your keyboard or mouse or on your controller. It goes up through the internet, goes to a server. The game calculates the next frame. And then using a new compression algorithm that we developed, it compresses the video in 1 millisecond and then streams it down through the internet, and then it appears on your PC or Mac or your TV screen. And this entire round trip, assuming the servers are within 1,000 miles, this entire round trip path happens in less than 80 milliseconds. Why 80 milliseconds? Well, 80 milliseconds is the threshold of perception from the point where you do an action and you see a result of an action. If you hit a button and within 80 milliseconds the screen updates, perceptually, you're controlling that action, and it's happening instantaneously. So to people, perceptually, Onlive, it seems like the games are running locally, all right? And this is all about why publishers will get rich doing this. But it caught the attention, of course, of all of these different publishers, which all the major game publishers, all the largest game publishers, except for Activision, have signed up so far. And we also have indies, like 2D Boys, actually 3 people essentially in a garage. They've done some terrific games. We want to show that we can go all the way from Electronic Arts to 2D Boy if we want to. And it's really good for game makers because they make one version, a SKU, stock keeping unit, what a SKU is. One SKU runs on TVs, PCs, and Macs. They don't have to port the games over different versions. And we start with their PC version that they already have. We've made our servers so they can take the PC version of the game and it just runs. You don't have to worry about platform transitions, like going from PlayStation 2 to PlayStation 3. You can't pirate a video game, and you can't have used games. So that solves the piracy problem. I mean, a movie, you can always pirate. You can point a video camera at the TV set or a microphone at the speakers. But if the game is running remotely in the cloud and it's playing here, you can't pirate it because every experience is unique, right? So it's a terrific thing not only for the US but for other markets. And we get terrific telemetry. I mean, here's a really cool thing. Now, obviously you can with private, if people allow from a privacy point of view, you can track what they're doing and see how well your game's doing. But this is really cool. You can do live beta testing on demand. So when you're developing a video game, you ever like get those things you put in the disk and like then it's got a 1-hour download, all right? Well, that's because you can't beta test a video game. What are you gonna do? Send out DVDs to people every week? You can't do it. So with Onlive, you'll see in a minute, you can spectate any stream. You can watch anybody using the system. So if they're developing a video game in New York and you have people testing it around the world, then you can go and send out beta, let people test it all around the world instantly because they do it off the cloud, and then they can view it. Then the person developing the game can watch little windows, of everybody playing the game, zoom it up. If the game crashes, we actually record like the last 15 seconds of the video, and then you can log into the actual server that was running the game and find out why it crashed. So it really speeds up development. Okay, so let's talk about video compression. Don't worry, I'm going to do a demo next. I think one more slide, all right? All right, so interactive video compression was designed for video games. So when my team developed QuickTime technology back at Apple, and back then we didn't have a term, the phrase video compression. In fact, I remember going to Apple management, I think we can get video to run on a computer screen. And they said, why would anyone want to run video on a computer screen? So I said, well, I'm not sure. I can think of a couple things, but it's got to be useful. And they're like, computers are made for desktop publishing. They're not made for video. So I said, well, I think before the Macintosh, computers were made for like spreadsheets and word processing. And then because you did this cool interface, we could do desktop publishing. How about we do something for video? And it was like, it was so hard getting it through the system and that's the kind of thing you'll be up against. You run into these paradigm shifts. Even a very innovative company, when you go and say, we got to do things completely differently, I mean, it's so damn obvious now that this is a good idea. But anyways, QuickTime in a lot of ways was pioneering a lot of the stuff. And then out of it, there was Flash, Windows Media, terrific work done by the MPEG groups over the years. In fact, contributions from this university as well. But anyways, all of those standards are based on what's called a group of pictures concept. The idea that you typically have an I frame, and then you have P frames and B frames. The B frames are frames leading up to the I frame. P frames are frames after it. But this group of pictures allows you to go and achieve high compression ratios because it exploits similarities between the pictures leading up to the I frame, which the I frame is like a JPEG of the image, and the pictures following after it. Okay. The trouble is that group of pictures ends up creating latency from the point you compress the video to the point you play it, because you got to get that whole group in before you can decompress it, right? There's other things like you have huge spikes in the video if you're trying to stream the video. If the video is spread over 1 second, like if you buffer it a little bit, then obviously those spikes, if there's a big scene transition, gets distributed over that second. But we don't have the privilege to do that. We can't wait. We have less than a frame time to compress the video in order to make Onlive work. So we had to go and figure out a new way to compress video that could achieve high compression ratio without dealing with a group of pictures. And that's what we're able to do. You ever like do a video teleconference, you wave your hand, and there's a lag? Okay, or you Skype or something, right? Okay, that's group of pictures is what you're looking at. It's just inherent to all compression algorithms. And people have taken it as a given. We stood back and said it Onlive, and we said, maybe this isn't a given. Maybe we don't have to do it. Even though kind of we started it here, maybe we don't have to go and do that concept. The other thing is broadband connections in the home are very, very unreliable. There's huge amounts of jitter. There's packet loss. There's packet reordering. Then people have problems in their home with routers. Routers will take certain packet structures, think that it's some sort of exploit, and they'll block it or delay it to wait for other ones. So we had to do all this practical stuff. I mean, literally, we went to thousands of locations, tried running video through to see whether or not we get it to work real time. In the end, what we ended up with is a compression algorithm that for standard definition TV, it runs at about 1.5 megabits per second, which is more than 7% of US homes. And for HD TV, runs at 5 megabits per second, which is more than a quarter of US homes. And of course, those numbers are just going up. Okay, last thing, you always have to deal with physics. Maybe you guys, someone here is probably going to figure out a solution for the speed of light limitations, but until then, we have to live with it, all right? So that limits our range to about 1,000 miles using the techniques we're doing. So if you take 1,000 miles over fiber, I think it's like about 16 or 17 milliseconds, but in practice, going through switches and everything else, it's about 21 milliseconds. So remember, we have 80 milliseconds to go and get this thing there and back, all right? So it's about 21 milliseconds round trip. Then that last mile, going through the cable modem service or going through your DSL service, you could have 25 milliseconds. Okay, one frame time in a game at 60 frames a second is 17 milliseconds. And then our compression is 1 millisecond. Decompression, like in a laptop or something, could be 8 milliseconds. Add all that stuff up together, you end up with about 80 milliseconds. So that's why we can only go about 1,000 miles away from a data center. But it's harder than that. I mean, you could be in Las Vegas, and you could easily find that you're getting a route through Seattle when, if you go and connecting to a service center where we have it in Santa Clara, California. And so we had to solve that. and we came up with a really, really cool solution for getting optimal routes through the internet. Instead of getting like a 100 gigabit connection from one provider, which is the typical way you set up a data center, and then you might have a backup connection, for if that provider goes down. We ended up cutting deals with all the major providers. So it's essentially, you think of it, we got 10 different providers like Internap, AT&T, Comcast are all tier 1 providers, and we have 10 gigabits from each of them, for 10 gigabits from 10 of them instead of 100 gigabits from all of them. So 100 gigabits from one of them. So if we connect to somebody here, we're fine, we're routed to Seattle, we'll try connecting to another provider until we find an optimal route. So that gives us a line of sight connection, a as the crow flies connection to wherever we want to go to from here. And it works. All right? So we solved the problem of random routing the internet, which was necessary in order to keep the latency at a minimum. Now, you do notice that people here in northern Montana are going to be left out. It's kind of cold up there and kind of sparse, but that's just the way it goes. But you guys have got great coverage, so what we're about to demo is from 250 miles away in Ashburn, Virginia. All right, so here's some demos, and click and go to Onlive in Virginia, with a data center in Virginia, and let's see. And we should bring up audio on this guy coming out of my mouth. Oh, it's up. It was because we were just listening to those videos. Okay. So there it is. Now the cursor is remote. So here I am moving the cursor, and it's running. If you're used to using, VNC, believe me, it's night and day. And the great thing about it, so this is a laptop. I mean, it's not a bad laptop as 13-inch laptops go, but what I'm about to show you can't possibly run on it. All it is doing, it has a 1 megabyte plugin that is just really doing decompression and doing some very sophisticated, interaction, feedback about what's happening with the internet connection. Here at Columbia, it's not that hard because you got so much bandwidth and so forth, but other places it's very difficult. So the first thing you notice is that big fly-in with all those little video windows. Those are beta users. Okay, so all the video from all these guys is being generated in the data center. We have it all routed in, and we're using IP multicast within the data center, so lots of people can watch them at once. Right now, we don't have that many beta users, so we're repeating them. Some of them are probably replaying videos and so on. But that's okay. But we can go and look at some people online here. And what you could see here is, let's see, here's somebody playing Frontline Fuels of War, so you can watch them. And let's go, and here's somebody else who's like doing a car driving game. And then these are actual games played, yeah. Yeah. Pretty cool, huh? So there's Unreal. What's this here? Oh, this is another indie. I love indies, okay? We just like, oh. So this guy sucks. All right. Yeah, I don't want to watch him. Okay, so here is Tomb Raider. All right. Yeah, and then here's Prince of Persia. So it's people playing all sorts of stuff here. So what's really cool, let's see if I can I love to find a sports thing to show. I don't know if there's anything going on right now. Anyone see baseball or anything going on? No. All right, well, never mind. Yeah. Oh, okay, here. Yeah, so like this is a multiplayer game, okay? And we're gonna have tournaments, and the best teams in the country or in the world, baseball is kind of a U.S. and Japanese kind of sport, and South America, but the best players are going to get together and they're going to play, and there's going to be final games. Okay, we've done the IP multicast stage. I mean, switches could do IP multicast. When you try it, you'll find they can get up to about 1,000 streams, and then we put them in a tree formation within the data center, so we can literally have 100,000 people spectating this live game. It's really, really cool. And if you have either a microphone, your PC or Mac, or the voice thing, you can cheer. We add all the voices together, so you get 100,000 people going, whoa, or 100 people boo, or whatever, or people shouting, and it's going to create a kind of stadium experience that's never existed before. And oh, this is an awesome game you haven't seen. It's Mirror's Edge. Oh, this is actually someone's playing the startup video, which is kind of cool. All right, but anyways, so let's go play a game. And so one of the games, we have lots of good games here, but one of the games, it's like, so you just go and choose what game you want to play. Like, off you go. Like, cool. So if you want to play Crisis here, so yes, okay, good. So first thing is like anybody who this is like the top players right now in Crisis, and so watch them live, and we know people are like, I've got to be the top player that everyone sees when they go to start up the game, right? You know, so you go and play the thing. Yes, a thing comes up and says how many spectators. You know what, this version of beta, and what happens is you get to 10, and it gets sucked in the 100,000, you know what I mean? So you know you're hot, you know. But